Our second video involving gravitational potential energy looks at the special case of taking an object from the surface of the Earth, so maybe a satellite sitting on the surface of the Earth. We want to move it into an orbit around the Earth. So we want to move it up some height, and we need to speed it up to some speed as it orbits around. So in this case, if we look at our conservation equation, it has potential energy to start. We have to do some work on it, right, to lift it up and speed it up. So here it has potential final up above the Earth, and it also has a kinetic final because when it's moving in orbit, it has a speed. So we have kinetic final this time to worry about. So this is negative gmm over Ri, which is radius of the Earth, plus the work you do, negative gmm over the radius of the Earth plus the height, plus 1/2 mv squared. Now, getting this velocity long way would be to figure out velocity by going AC equals g prime for up at that altitude. So v squared over r is equal to gm over r squared. You can work out that your velocity is the square root of gm over r. That's one way you can approach that. I would say the easier way to approach that would be, remember what we talked about in class, is the idea of the virial theorem. And the virial here tells us that the kinetic energy is equal to negative 1/2 the potential, which means that it's negative gmm over 2r, which really makes it positive gmm over 2r. So if we take that term and sub it in for Ek, our total energy on the final side of this is going to equal EP minus 1/2 EP, which equals 1/2 EP. So we can work out the final energy and the final total energy at the end as being negative gmm over 2r, and this is our total energy at the final side. And remember, we're only going to use this if the question's talking about putting something into orbit, or if it starts in orbit and travels down. Oops, cut off there. We see the end part of that. So our total energy is negative gmm over 2r.